Hi guys, I hope I'm audible. Looks like Caspian has joined. Hey Caspian. Mm, Hey Sahil, how's it going? Uh, okay, I can't see the view count yet, but I think it's working. Sahil, can you see my screen? Yes, let's go. Mm-mm. Let's just wait for some time for people to join. Just wait for 5 minutes and then we can start. I think you guys already know what we're going to talk about today. It's obviously USDC. Okay, I think there are people coming in. Mhm. Sahil, am I audible? Is there some background noise or is the voice fine? Hi, Satish. Mhm. So we've got Mark Zuckerberg on our screen. So today's stream is going to be interesting for sure. Honey Tyagi has joined. How's it going? Okay, I'll just wait for another 2 minutes and start. In the meantime, I'll share the resources for this stream, for today's stream. So there's obviously a GitHub repo. I'll just share that here on the chat. You guys can just open it up, set up your, um, set it up. And there's obviously our Kwala dashboard, which is what we're gonna use. And I think you guys can get Kwala credits as well to try out whatever we're gonna build tonight. So just drop your address or details in the chat or in our Discord server so that you can get Kwala credits. And I think there's a page as well to get Kwala credits, right, Sahil? So maybe you can get it from there as well. Hi Kuldeep. Okay, I think we have enough people to start off. Okay, I'm not audible. Let me just check. Okay, am I audible now? Okay, now it's fine. Cool, cool. So recently, not even recently, I think this just happened yesterday. Meta just did a partnership with Stripe. I think you all know what Stripe is. It's this platform for payments which everyone uses around the world for crypto stablecoin payments. So basically it's USDC payments for creators, for Meta creators. And this is pretty big for our ecosystem, for the whole Web3 ecosystem, because USDC is what's powering pretty much all of the crypto rails in terms of DeFi apps, as well as other crypto protocols like NFTs and creator platforms, including Meta, Facebook, Instagram, as well as your crypto Twitter. So this is a pretty big news, and our topic for today is going to be about building something related to USDC, related to stable coins in particular. We'll be building something called a bridge. I don't know how many of you have used a bridge in the future, or have in the past, or have heard about a bridge. So I'll just start from scratch what exactly a bridge is, what its job is, and how to build one really easily without setting up complex infra, just setting it up using Kwala. So a bridge is basically a way in which you transfer assets or tokens from one chain to another, one blockchain to another. So you might know there are multiple blockchains. You might have heard about Ethereum, about Polygon, and many others. But I'm pretty sure at least people would have heard about Polygon at least, and Ethereum. And we're going to basically build a bridge that does swaps of the USDC stablecoin between different chains on the Ethereum ecosystem. So we'll just pick up two chains which are on the EVM ecosystem and try to build a bridge between them. To give you some more context about stablecoins first, before we dive into the bridges part, there's some interesting things that have been happening recently over the past couple of months. One is obviously the most recent one, which is the Meta launching stable USDC payments for creators. Then there's obviously the regulatory framework that the United States laid out. They call it the Genius Act. I think that's what they call it. It's basically to provide regulation for stablecoin payments. And there's obviously the AI agents have become really popular, and they use stablecoins a lot, especially the X402 protocol, which is an internet native standard for payments, primarily using crypto, and even in crypto, to be particular, it uses stable coins. And yeah, so USDC is the most popular stablecoin, and it's used by pretty much every decentralized app in the world right now. It's used by companies building in crypto, even by companies who are not crypto native, even they are using stable coins. It's used by enterprises. So it's like this really important part of the blockchain ecosystem, and being able to use it for your own product or for any task that you're doing for your company or your project is a really important part, because everyone wants a stable coin. They don't want some volatile token, like they don't want to use Bitcoin for making or receiving payments for their apps, because people don't want volatile tokens, right? They want something stable. So it's obviously pegged to the United States dollar, and it solves a lot of these pain points for users as well as builders. So what we're going to do is obviously build a bridge to transfer these stable coins among different chains. The reason being, there are so many chains right now, and a lot of these apps are built on different chains, and the users, they would probably have tokens on one chain, tokens like USDC, and they want to quickly and easily transfer them across different chains, right? They don't want to spend a lot of money to do those transfers, or spend a lot of time to do those transfers, right? They want a seamless experience. So how do they get to do that? That's where we are coming up with building a bridge. Okay, so what we did here is we built a simple interface where people could just connect their wallet, their MetaMask or whatever wallet they're using, to transfer funds from one chain, an EVM based chain, Ethereum like chain, to another. So we obviously built a really simple prototype just to get the idea, get the gist of how it works, but obviously it does support pretty much all the popular chains. So what would the user experience look like? They would just come here, and for now we have allowed transfers from the Ethereum testnet to the Arbitrum testnet, just so that people can try it out without using any real money. And they connect their wallet, they select some dollar amount. They have so I've connected my wallet here, and I've got a little bit of USDC here. I'm gonna maybe transfer a really small amount. So I'm gonna sign my transaction. It's approved, and then I'm gonna sign this other transaction, which is called burn. And it's burned. Okay. What's the next step? It's saying Circle attestation. What's this? Circle is actually the company behind USDC. Circle actually built the USDC stablecoin. So it's really doing all the heavy lifting. And attestation is a way in which they kind of, to put it in simple words, they not the company Circle itself, but these nodes of Circle, which are run by different people. They verify that okay, this particular request for transfer has been sent, transfer from in our case from ETH Sepolia to Arbitrum Sepolia testnet, and they do all these checks, and then they burn the tokens on the source chain. In our case, the source chain is Sepolia Ethereum, and then they mint it on, once the verification is done, they mint it on the destination chain, which is Arbitrum. So what is happening here is we have a post endpoint, like it's within this front end itself, our Next.js app. We don't really have a backend here, which is called by some service, some backend, or some server to check if this attestation process has been completed and if the verification is successful. Now you must be thinking, okay, you said that we don't really need backends and servers and all of this overhead, so how are we going to do this? This is where Kwala comes in. Kwala is the automation layer for Web3, where you don't have to have some backend or buy some expensive RPC service to interact with blockchain nodes. And our app is here on Kwala, app.kwala.network. Okay, hi. GM Lara Dev, GM Akhilesh. Okay, so coming back to Kwala, I think I've dropped the link as well. Yeah, I've dropped the link. So what Kwala does is it handles all this backend stuff. It does these API calls or these blockchain smart contract calls that typically would require a backend, as an expensive server or RPC node, but we're going to do that in a pretty simple way. So if we just see our interface, it's going to call this API attestation service. So we want this to be called on a regular basis on some time interval, something like a cron job running at some interval, so that it checks whether the verification is done or not. So to do that, we are going to build a Kwala workflow. So the first step is come to the dashboard and click this new workflow thing, and you get a workflow builder here. So I'm going to open up this workflow builder and give it a name. I'll just call it bridging USDC checker, something like that. And the next step is this trigger configuration. So what is this going to do? We want to have this cron job to hit this API endpoint so that it can check the circle attestation service, right? So we want an API call to be repeated at some particular time interval. So I'm going to select it should start immediately and repeat at a certain time interval, and I'll say something like 5 minutes or even lesser. Every minute, that would also work. And I'll set an expiry, some date in the future, so maybe something like okay. The next step is an action. So what's an action? Trigger is the condition that we set earlier, and the action is whatever we want to do based on those triggers. So the trigger was a time interval, a cron job. So in this case, we just want to call this API endpoint. So it's on this URL. We just copy that from here and paste that here, and the endpoint is this one. So I'll simply paste it here, and we can just name this action something like check attestation, and it will be an API call. We don't really need a payload because there is some parts which are done by a smart contract, which I'll just come to in a moment. So we're just going to go ahead and click next and create workflow. And there are just 3 simple steps. First is the compile to make sure your workflow syntax is correct, and then save it. It's just going to pop up your wallet. You just need to confirm it, and once it's saved, you just need to click deploy, and it's just the deploy transaction. It will take a few seconds to deploy. It's really fast, and yeah, deploy is done, and you basically have your workflow ready. Yeah, so deploy is done. And to come to the next part, which is what's happening under the hood here, is that we are tracking the changes that are happening. Like, let's say I'm a user and I come to this interface and click this. It's going to burn my tokens, and it's going to keep track of this in a smart contract. So we wrote this little smart contract to keep track of these changes. This is a really simple contract which we are calling the registry, and what it's doing is basically registering this user's request. In our case, this request to transfer from Ethereum to Arbitrum, and it's emitting an event called request registered. And after this is done, the polling thing is done, like the workflow that we just set up to watch for these watch for the attestation service, poll the attestation service. That is done every 5 minutes, and you can actually track that in the actions page on our Kwala dashboard. So there is the actions page. I think my internet is a little slow. Okay, so you'll basically be able to track it there. Coming back to the contract, so once the request is registered, our Kwala workflow keeps checking that, and once that particular thing is done, the checking part, that okay, whether the attestation is successful or not, then what do you need to do? Okay, voice is not too clear. Is my voice okay now? Okay, if possible, check your mic. There's some distortion. Okay, just give me a second. I'll just try to do something about this. Okay, I think the voice should be better now. Okay, cool. Okay, so once this check by Kwala is done, like the polling thing which just keeps happening, what we're going to do is we need to make sure that once it's checked, the user receives these funds on the destination chain. In this case, the destination chain is obviously Arbitrum, so we need to make sure that they receive those funds. And what usually happens in most bridges is that they need to go to that chain, like go to the interface and switch their wallet to that particular chain, the destination chain, and then click some button and do a transaction again. So they need to sign another transaction to do the receive. Instead, what we're doing here is using Kwala to do the receipt automatically. So they don't need to do another transaction on the other chain to claim their funds on the other chain. So to do that, we have a function here in our smart contract which is called mark attested, and it has this request completed event. So this function is actually called directly from our front end interface, but this is not the one which actually does that receipt transaction. So that needs to be done by a wallet. In our case, it would be done by the Kwala smart wallet, which is something we have built, and it doesn't take your funds or anything. It never gets sold of your funds. It just signs transactions on your behalf. It doesn't have access to your funds as such. So as you can see, this mark attested function, which is called from our interface, has this event emitted. What we're going to do is watch for this event. So what this means is that the attestation part is complete and it's verified. It's good to go to be accepted, like the user can accept it now. They just need to sign that transaction. So once this is done, we are going to call another function which is a USDC contract, the circles contract available, which I'm just going to show you here. It's actually called it has a function called receive message. This is the function that the user needs to call to claim their funds, and in that they need to pass something called a message which has the data or the metadata about the transaction details. In my case, it would be my address obviously, and the source destination chain, as well as some other important data which the attestation service has verified. And that particular data is basically converted into this format and sent to this passed on to this receive message function, which is actually there on this contract. So this contract is not something we've written, it's something the circle people have written. So I'll just show you this contract as well. It's there on every chain that circle supports, but in this case we're going to do it on the destination chain, which is Arbitrum Sepolia. And yeah, if we see the functions, it has got this receive message function and message bytes and attestation bytes. So we're going to pass these two using Kwala. And if you see here, there are these two parameters, which are these something we call target parameters, which are passed on to this function. This is the first one, this is the second one. You must be wondering what are these re.event. It looks a little cryptic. So let's just go to the start of the workflow. So this is our second workflow. The first workflow was the polling thing, the polling workflow that we had built earlier, and the second one is the claim workflow. So this is going to call the receive message function, and the trigger in this case is an event, right? Earlier we selected a time interval, an immediate repetitive time interval, but in this case we're going to configure the workflow for watching events, and for every event happening on this contract, okay, this is a different contract. What's this? this is the contract that I had shown you earlier. This is the contract we had written for tracking the, all the events happening on our interface. So this is the registry contract. So on this particular contract, we want to track the request completed events. So I'm going to just obviously paste the address here and select the chain, which is Sepolia, and paste the ABI here, and then select the event that we're interested in. It is the request completed event, and we're going to do the same for the recurring configuration because we want this tracking to happen every time this event happens. So okay, this is our trigger configuration, and the next step is an action. What do we want here? We want the user's funds on the other chain, on the destination chain, to be claimed automatically. So to do that, what are you going to do? We are going to call a smart contract this time. So earlier in the previous workflow, we did a post API request to our Next.js app, our Next.js route. And in this case, we're going to call this contract. This contract is obviously the Circle's contract to claim funds. So we just pasted that, selected the chain, our destination chain, which is Arbitrum, Sepolia. And if you see, there is a smart wallet here. So Kwala has a lot of smart wallets supported on the EVM chains. So you could create a different wallet as well. I'll just use the default one, and I'm going to just use the function that we're going to call. So in this case, it's receive message, and the parameters are these two. So I just paste this much here, and that's it. That's all I need to do. And yeah, I've already deployed this workflow, so I'm not going to do that again. And what this does is, whenever this event happens on chain, then this function is called, and the funds that the user is supposed to get, it basically goes to their wallet on the Arbitrum, on the destination chain. In our case, it's Arbitrum. So as you can see here, if I can even check it manually, but obviously Kwala does it for me. It's saying the attestation is ready and my funds would be there in my wallet on the Arbitrum chain. So that's pretty much the flow that we built out. So building a bridge has become this simple now. You don't even need to deploy nodes. Obviously we are using the Circle service, but still you would need to do some setup to get this working, get this automatic flow working within your app. This will help you focus on building your app, which might use bridging, which would most definitely use bridging because people have funds on different chains. They don't keep it on one particular chain. So you would obviously need some sort of bridging, and you would have to set up servers to automate this flow, the receipt flow, or even the attestation flow. It would be done automatically by Kwala. And to deep dive, if you want to deep dive into this technology that Circle has built and we're using it here, it's called CCTP, cross-chain transfer protocol. We obviously have all the contract addresses necessary in our GitHub repo, and you could obviously do some you could read up more about it. So this is what we have been using. Okay, I'll share the link as well. Link to that as well. I'll add it to the GitHub repo. And yeah, this is kind of the future. Not even the future. It's the present, because USDC is being used by every company, and even people who are not in Web3, they're using USDC now. So it's something you would most definitely use in your Web3 app, and bridging is something you would definitely need to implement. So I think this is pretty much it, and I would love to answer your questions about bridging, about USDC, about Kwala, or anything. Dhirendra Pratap says session is going too well. Thank you. Vlara Dev is saying interesting topic. Yeah, definitely interesting topic. Okay, so I'd like all of you to try this out on your own. Try out Kwala, and give your feedback. I think I didn't join on Discord today. I'll just check the Discord as well. So if you guys have questions, you can just come on Discord and ask your questions there. You could just unmute your mic and ask your questions. Okay, cool. Or you could just drop your questions here on the YouTube chat. That would be faster. Whatever works. Okay. Cool. I think that's pretty much it. If anyone has anything to add, please do. I'm there on the Discord as well, so you could just come to Discord as well if you want. I'll just wait for 5 minutes. Okay, while I'm waiting, I'm just gonna check out what Meta has been up to. Meta and Tempo and Stripe. By the way, Stripe. So creators, Instagram creators would get payments on USDC, it seems. Okay, Polygon. Kwala supports Polygon, so maybe Meta could use Kwala. Or anyone building some creator app could use Kwala as well. Nice. So this is actually the cross-chain transfer protocol. It basically works by burning a token on the source chain and then verifying everything and then minting it. Minting means creating it on the destination chain. So that's how this particular protocol works. It's pretty simple. It's pretty much decentralized. and it's fast. Cool. I think there's okay, you guys can obviously keep dropping your questions on our Discord. I'll take a leave now, and yeah, just feel free to drop your questions there. See ya. Bye bye. Thank you, everyone.